Relativity problem number 2. Angular velocity versus revolutions per minute. The Earth turns about its axis. The axis goes from the north to the south through the center of the Earth. All points on the Earth turn around this axis, perpendicular to that axis, not at any other angle. Now, relativists, when dealing with the question of a relativity problem number 1, will call for revolutions per minute to be the factor by which their mathematics resolves the problem. The problem with revolutions per minute is that whilst it's true, it's also entirely inappropriate for dealing with the problem. So, the Globling will say, if you look at the hour hand on the watch, that hour hand will make 2 turns across the face of the watch, all the way around, 2 turns per day. That would be 24 hours. And that's how slowly the Earth turns. That's true. That's true, especially for any point 1 centimeter away from the axis of the Earth. So for this example, we will say that the axis of the Earth is a hair's width. That's how wide the axis of the Earth is. And it goes from north to south, directly through the Earth. Now, if you were standing 1 centimeter, or if you're considering a point 1 centimeter away from this axis, then the objection of the relativists is correct. Very, very slowly the Earth rotates, incredibly slowly. However, nobody's discussing the rate of Earth's revolutions at 1 centimeter from the axial point. We're discussing the revolutions, or the speed, or the potential, or the effect on the surface of the Earth. So you see how relativists can't deal with that. So instead, they shift goals and answer an entirely separate question. The question is, what's the centrifugal force on the surface of an Earth 3,959 miles in radius, rotating at 1,000 miles per hour at the equator? That's the question, not what's the force exerted 1 centimeter away from the axis. So we'll go back to the watch. You might have noticed, by the way, that there's a watch on your screen. I hope you noticed it. I hope that's clear, not difficult to see. Anyway, we'll go back to the watch and we'll consider that hour hand. And for this example, we will say that the seconds are beating half as fast, just for ease of imagination for the Globelings, and we will pretend that the hour hand moves half as fast. So it makes 1 revolution per day, very slowly. Let's pretend this is a 24-hour watch. Now, this 1 centimeter away from the axial point of the Earth, so anywhere along that axis, perpendicular to that, 1 centimeter away, this watch would then describe that perfectly. Now, extend that hour hand. That's the shorthand for all you digital people. Extend that hour hand. Make it 3,959 miles long. And imagine standing on the tip of that hour hand, just like Einstein did when traveling from Oxford on the train, imagining that the train wasn't moving, but the landscape was. So now you imagine that you're sitting on the tip of that 3,959 mile long hour hand, and you're not traveling as slowly as this is right now. You're traveling at 1,000 miles per hour. Now, unless you've traveled in a supersonic jet, you've never traveled at 1,000 miles an hour. Now, imagine that you're sat there gripping onto the triangle that's the tip of the hour hand. At 1,000 miles an hour, this is spinning you. Just like at an amusement park, you might have the chained swings. So you have swings hanging on chains on a carousel that spins. And as it spins, you swing out with the centrifugal force being kept from being flung away by the centripetal force being exerted by the chains. But you're hanging on to this little triangle 3,959 miles away from the center that this hour hand is turning around, and you're traveling at 1,000 miles an hour, and you're holding on, because if you don't hold on, you're going to go flying off, aren't you? Well, that's the question, and that's the problem that relativists cannot answer, which is why instead they answer a question as if it was related to revolutions per minute, in which case they can equate it to a point 1 centimeter away from the axis. Thank you.